Hey everyone, I am Vaibhav Khandelwal and I welcome you all to Simplilearn's YouTube channel. In this session, we will talk about circular linked list. We shall begin our session by introducing a circular linked list. Then we will try to implement it in the code editor. After that, we will try various operations on them like insertion and deletion. Finally, we will sum up what we have learned in this session. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. So without any further ado, let's get started with introduction to circular linked list. A circular linked list is a linear data structure made up of nodes. It is like a single linked list except its last node points at the head node. These nodes consist of two parts, data and reference to next pointer. These nodes can be traversed using the next pointer. Now let's try to implement it in the code editor. We will start by creating nodes. To create a node, we need a class node. We will define its members as public, int data, and node pointer next. Now let's write a function to insert a node at the beginning. Void push we will use arguments as a pointer to node pointer head and int data. We will define a node, new node equals to new node parenthesis star head. Now we will put in the data into the new node. Since we are inserting at the beginning of the linked list, that's why this new node's next should be the head pointer. If linked list is not null, then set the next of the last node as head. While temp next is not equals to head, the temp is equals to temp arrow next. Now temp next is equals to new node. Else new node next is equals to new node. Star head equals to new node. Now let's write a function to print this linked list. Void print list node star head node star temp equals to head if head is not equals to null, then do cout temp data temp equals to temp next. Now while temp is not equals to head, this condition is important to stop this loop so that it doesn't go infinitely. Now let's go to the main block. Let's initialize this list as empty. Node star head equals to null. Now let's insert some nodes in this linked list. Push ampersand head comma 2 push ampersand head push ampersand head comma 11 ampersand head comma 5. Now this linked list looks like 5 11 9 2, then it will again go back to 5. Now let's try to print this. Cout circular list head. Now let's try and execute this. As you can see, we have successfully created our first circular linked list. Let's get back to our slide. We have now introduced the circular linked list. Now let's discuss some of the operations we can apply on a circular linked list. We can perform two operations on a circular linked list. First up, insertion. We can perform insertion at three different situations: at the beginning, at the last, and at a specific position after a node. Next up, deletion. We can perform deletion at the three different situations. First up, at the beginning, at the last, and at a specific position after a node. Let's discuss these in detail. First up, insertion at the beginning. We have to give the first node's address to the new node's next pointer to execute this. Next up, insertion at the end. We have to give new node's address to the last node's reference pointer. Next up, insertion at a specific position. We will change the previous node's reference address to the new node's address and the new node's reference pointer to the next node's address. Now, let's try these operations in a code editor. So far, we have implemented a linked list using classes. Now, let's try to implement it using structures. We will start by creating a struct node with its element as int data and struct node next. Now we will write a function which can only insert a node to an empty list. Struct node star add empty. Struct node star last comma int new data. Now since this function is only for the empty list, so we will have to check if the linked list is empty or not. If last is not equals to null, then we will return last. Now let's create a node dynamically. Struct node start temp equals to struct node star malloc size of struct node. We will copy this statement because we will need it in the future functions. We will assign the data to this new node. Temp data is equals to new data. Last is equals to temp. Now we will create the link. To do that, we will use last next is equals to last. Since we are in an empty list, so the first node will always point to itself. Return struct node start. We are creating a function to insert at the beginning of the linked list. Struct node star add begin. As argument, we will use struct node last comma int data. If last is equals to null, then we will return add empty last comma data. Now we will create a node dynamically. I've already copied this statement for the ease. Now we will put in the data. Data is equals to data temp next is equals to last next last next is equals to return last. Now we will write a function to insert a node at the end. Struct node star add and struct node star last int data. If last equals to null, then return add empty last comma data. Now we will dynamically create a node and put in the data. Temp data is equals to data temp next is equals to last next. Now last next is equals to temp and last equals to temp. Return. Now we will write a function to insert a node after a specific node. So struct node star add after struct node star last comma int data int item. This item is a node after which we have to insert the node. If last equals to null, then return null. struct node star temp comma star p is equals to last next. Now do if equals to item temp equals to we will dynamically create a node here. Temp is equals to struct node star malloc size of struct node. Now we will put in the data. So temp data is equals to data temp next is equals to next. Now p next is equals to temp. If p is equals to last, then last is equals to temp. Return last. P is equals to p next. While not equals to last next. Cout item not present in the list. Return last. Now we will write a function to print this list. Void print list struct node star last struct node star p Now if last is equals to null, then cout list is empty and return. Else we will point to the first node of the list. So p is equals to last next. To traverse the list, we will use do while loop. So do cout data is equals to p next. While p is not equals to last next. Now let's write a code for the main block. We will start with an empty list struct node star last equals to null. Now last is equals to add empty last comma 6. Last equals to add begin last comma 4. Last equals to add begin last comma 2. Last equals to add end last comma 12. Last equals to add after last comma 10 comma 4. Print list let's execute this. As you can see, we have created the linked list in the correct order. Let's get back to our slides. Now, let's talk about deletion. First up, deletion at the beginning. We have to change the first node's address to the null to execute this. Next up, deletion at the end. We have to change the second last node's address to null to execute this. Next up, deletion at a specific position. We will change the previous node's reference address to the next node's address. Now, let's try these operations in the code editor. Let's get started with creating a node. To create a node, we need a class node. We will declare its members as public, int data, node pointer, next. Now we will write a function to insert a node at the beginning of the list. Void push a pointer to the node pointer head and int new data. Now let's create a node and make head as next of it. Node star new node equals to new node parenthesis. Let's put in the data new node data is equals to new data and new node next is equals to head. If linked list is not null, then set the next of the last node as the first node. If star head is not null, then we will find the node before head and update next to it. So node star temp is equals to star head while temp next is not equals to head. Temp is equals to temp next. Now temp next equals to new node. Else new node next is equals to new node and star head is equals to new node. Now let's write a function to delete a given node from the list. So void delete node. Its argument is a pointer to the node pointer head and int key. Now if linked list is empty, then we will simply return it. If star head is equals to null, then return. Otherwise, if head head data is equals to key and head next is equals to head, then free head head is equals to null. Return. Now node last is equals to star head comma star d. Now if head is to be deleted, then star head data is equals to key, then while last next not equals to star head, then last is equals to last next. Now we will point the last node to the second node of the list. Now we will free this head star head equals to last next. Now if either the node to be deleted is not found or the end of the list is not reached, then while the last next is not equals to head and last next data is not equals to key, then last equals to last. If node to be deleted was found, then if last next data is equals to key, then D is equals to last, next, and last, next is equals to D's next. Now we will free D, or else C out no such key found. Now let's write a function to print this list. Void print list node star head node star temp is equals to head if head not null, then do cout temp data temp is equals to temp next, while temp is not equals to head. Cout. Now let's write a code for the main block. We will start by empty list. So node star head equals to null. Now we will push ampersand head 2, push ampersand head comma 5, push ampersand head comma 7, push ampersand head comma 8, and push %head, 10. Now we will print the list before any deletion operation. Cout list before deletion. Print list head. Now let's delete %head. Let's delete 7. Cout list after deletion print list head. Let's execute this. As you can see, our deletion function is working perfectly. Let's get back to our slides. At last, let's sum up what we have learned in this session. First up, we have recognized circular linked lists as dynamic data structures. Next, the circular linked lists offer faster insertion and deletion operation. Next, a circular linked list are unidirectional in nature. That is, we can only traverse it in one direction. Finally, a circular linked list traversal is quite tricky as we have to stop the loop as soon as we revisit the first node. Otherwise, it will traverse it indefinitely. And this was all for today's session. Hope you guys found it informative and helpful. If you like this session, then like, share and subscribe. If you have any questions, then you can drop them in the comment section below. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.